All right, so we talked about quantum model last week, and so we'll just do a little bit of review, and then we'll talk about how we use that model to describe the structure of the atom. So if you've been gone, that's okay. Yes, so on the diagrams, on these diagrams, in your notebook. So we're starting with.
Wait, how did she get? Why don't I get anything?
Do you need these?
Yeah, she needs them. Me too. I just had like so many emotions.
I have to take my freaking sister by the dentist way outside. My car's going to run out of gas. It is not getting. No, I can think.
All right, so the first component of the quantum model has to do with the distance that the electron is from the nucleus. Just like in Bohr's model, starting with the ground state, and we had several different excited states. Same idea, the electron can exist at different distances from the nucleus. Okay? We call that the principal number.
The quantum number.
Principal number, and so that describes the distance. Okay? And we can have 7 different levels depending on how many electrons we need, how far that is going to be from the nucleus. So our principal numbers are going to be 1 to 7 depending. Okay?
My house is using
Okay, next is angular momentum.
Yes, that's the colorful one.
And if you were here, what does angular momentum describe?
The shape. 4 different shapes. Which one is the distance?
What I have is frozen. It's a Wednesday. Okay, angular momentum, that describes the shape. How many different shapes can our orbitals take? 4. Okay. Next component is the magnetic number. And when you think about that, magnetic, think compass. Magnet telling you the direction. So our magnetic number tells the direction that the shape. Yep, the orbital is pointing. Okay, and we'll see that as we start to look at each of these elements today. Okay, and then the last one was spin.
Clockwise or counterclockwise?
Yep. And when we look at any of the shapes or any of the orbitals that an electron can be in, any one can hold 2 electrons, one spinning clockwise, one spinning counterclockwise. And so what we're going to do, we're going to use these to look at the structure of the first 10 atoms. Okay? Bohr model. If we were to draw a picture of the Bohr model showing the structure of hydrogen, what are some things that we're gonna include in our drawing?
The electron.
We're gonna include the electron, how many?
One.
One electron, what else?
A proton.
Nucleus with how many protons? One. Okay. So the Bohr model is gonna show a proton in the nucleus
Here he is.
and one electron in its ground state. How many excited states are there? 7. Okay. And how did Bohr know that an excited state was a thing that could exist?
He just kind of did.
Because it.
Because what happens when the electron moves
Photon of light.
between?
Photon of light.
Yes. So when the electron gains energy and moves to higher states, when it comes back down, it releases a photon. And so, based on his equation, there are 6 different excited states that the electron could be.
Yes.
And depending on how far it moves up and how far it moves down, because it can do any kind of combination, we get different colors of light.
Yes.
All right, boom.
I wholeheartedly agree.
Bohr model. Okay, but that didn't fit, so they came up with the quantum model,
Oh God, they made it.
which was a better way to describe how more than just one electron. Bohr model worked really well for hydrogen. Didn't work for other elements. So we're gonna look at that today.
White.
All right. So what would hydrogen look like in the Bohr model? So what are some things that we're gonna keep the same?
The proton and the neutron.
Yep, one electron
Oh, electron.
and the nucleus with
The proton.
one proton. Right, that's all gonna stay the same because that's what we know about hydrogen. Okay, but we're gonna think about it just a little bit differently. Okay, so we're gonna have a proton in the nucleus, and that one electron is gonna be close to the nucleus, and it's gonna be in the first energy level or the first principal number. Okay. And the shape of that is going to be a sphere, so we're going to call that S. Okay, and then direction. Do spheres point in a direction?
No, they're just.
No, so there is no magnetic number. 0. And then how many electrons are going to be in this
One.
space? 1. And to show it spinning, we're going to draw it with an up arrow.
Mm.
Okay? So that's our electron in that space. So this might be what we could draw for the structure of hydrogen in the quantum model. We have the nucleus with a proton, one electron in the first energy level in an S shape. Okay? So hydrogen. Okay. What do you think helium's going to look like? 2.
2 electrons.
Helium has 2 electrons, 2 protons. So in its nucleus, we're going to put 2 protons. Is that electron going to go in the first energy level?
No, we do it.
Yeah.
Because
Two
the
will be in
electrons
first.
can stay.
Because they
Well,
can hold 2 for
It can hold 2, so we've got to fill it up.
So
So
yes.
we're going to put one here.
And the other one in there as well.
Okay, so this is going to be, we're still in the first energy level, and we're going to have 2 electrons, but they're not going to be spinning the same direction. So we're going to show one spinning up and one spinning down.
Where are the arrows here?
How do you?
The arrows represent the direction that the electrons
Why
are
is there
spinning. So
flying?
clockwise, counterclockwise, and there's 2 of them, right? One spinning one way, one spinning the other.
So instead of drawing the dot.
Yeah, so instead of drawing the dot, right? The Bohr model, because we're thinking about the electron as a particle, the electron is on the orbital. But since it's a wave, this is just the space, it's in there somewhere. And that sphere represents the space that it could possibly be in.
Would it still be a sphere or would it be the P one? P hat? No.
No, not yet. So we're in the lower energy
Oh,
levels,
yeah,
there's just
there's
S.
some-
We're still on first. Okay,
Okay.
now we can see, can we fit any more electrons in this energy level?
No, so you have to go to the next.
No, so we have to move farther away from the nucleus because this one is full.
This
So, for lithium, it's got 3 protons. Okay. And where are the first 2?
in the first level.
Right, the first 2 are going to be here. 1s. Okay. Now where's the third one?
The second one.
So we add an energy level farther from the nucleus. Okay. So now this is the second energy level. Like think about our bullseye. It's also going to be a sphere shape, so we call it S. And we only need 1 electron, right?
Mm-hmm.
So we'll just put 1 in there. You see it's spinning.
That way.
Does it matter which direction?
That's too
It doesn't. By convention, we typically go up arrow first, then down arrow. But it doesn't. Okay, 3. Okay. So following our pattern here, where are the 4 electrons for beryllium going to go?
in both.
The first and second.
Yep, we're gonna have 2 there, and then we're gonna have 2 there. Okay? Then, just thinking ahead, can we put any more in that 2s?
No.
No, so then we're gonna have to do something different.
There we go.
So, beryllium. Uh, 4 protons. One S. And 2s. Okay, so how do we feel about this? Like, is this like, okay, we're just adding electrons, like mapping them out. Where do they go? All right. So, since we cannot put any more here, we're either going to have to go farther away from the nucleus, or add a new shape. Okay? And for boron, we're actually going to add a shape instead of going to the next energy level.
How do you know which one is good?
What's that?
And how do you know which one is good?
So right now I'm telling you, just because, you know, as we go through it, but when they were first mapping it out and using the quantum model as a way to figure it out, when they would excite these electrons, right? Because don't forget any of that stuff, right? So when they would excite these electrons and get the energy of the photons, they mapped out kind of the second energy level shape. And then it wasn't until you went to bigger and bigger elements that then you would go to the third or the fourth energy level. So, you know, they're exciting electrons and getting that photon energy and mapping it out. So how do we know? Because the photon from that electron has so much energy. So, when we go to boron, which has 5, the first 2 are going to be in the 1s. The next 2 are going to be in 2s. Okay, but, and we'll talk about this after you guys draw this, because I'm going to have you draw this. There are 6 more electrons that have very similar energies before you go to the 3rd energy level. So how are we going to fit 6? Okay. Well, this is where the shape comes in. And in the 2nd energy level, the electrons start taking on, their orbital shape starts taking on a different shape. Okay. And this is where we start taking on the P shape. Okay. But the important thing about the P shape, so if you look at one of these, okay, this is one space that the electron can be in. And what direction is that pointing? Up and down. Okay? So is that X or Y?
Y.
Okay. Then what about this one? Yeah, it's pointing side to side, so this one's X. Okay, and this is one space. The X space is one space. All right? And then, what about this guy here? Z. Okay. Again, this is one space. So when we start with boron, so boron starts looking a little different. That last electron, like where do we put that next electron to go to the next element? Well,
The top of water.
we have 3 different places to put it. We can put it in X or Y or Z. We'll just start with X. And we'll put 1
This is the
electron.
most.
Okay. All right. Sure. So, what's the next element?
Carbon.
With 5, right? And then nitrogen?
Yeah.
With 6, oxygen, no. Yeah, oxygen. Oh, wait.
Yeah, I'm confused.
I am
Carbon
confused
has
too.
6.
Carbon has 6.
Nitrogen has 7.
Nitrogen has 7.
I'm like looking between the board.
I am too.
The board and the chair.
Oxygen
I'm like,
has 8. Fluorine has 9.
Are we drawing those?
And you're going to draw that.
Yay.
And neon
Oh, so I don't-
has 10. Okay. So, here's what I'd like you to do. Who wants to take carbon? Who wants to take nitrogen? Who wants to take oxygen?
That was so.
Who wants to take fluorine?
That was so like majestic. Like, because it was just like.
They took all my other markers.
Mr. Scribner, you need to have a chip.
That's a 6. No,
Yeah.
Yeah.
Neon.
That is so real, Tony. Like, add nitrogen.
You have a chair stand?
Yeah.
You don't have to draw it up, draw it down.
Draw it like right here.
Yeah.
No, because then I won't have enough space at the bottom.
For what?
Yeah, right here, Mom.
Yeah, I can do that one.
And then my handwriting is very bad.
And if you need an assistant, have somebody come up there and assist.
I have to draw all 6 of them.
Wait, what do you got? spaces. Oh, just the ones that were occupying the active rock?
Yeah, that's fine.
And only 2 in each thing, right?
Yep.
Sure.
Yeah.
I don't know that. You guys doing that one?
Done.
I don't know if that one helps.
Done.
That's ugly. Stop with me, because mine's ugly.
You're doing that?
It's really cute. My name is Karen. So phase.
Oh, that was it. It should have.
Misshapen.
No, 'cause it's.
Oh, there's something.
You have to put yours in 2, 4.
With the spaces, can I only put one
Wait,
here?
how many are we gonna have?
You could do it that way, then. Or you could put them together.
Like that?
Yep.
We got 11 of these.
Have basketball.
6. And then.
How do you measure?
Or you put 2 in this one. Putting 2 in that one is the same as putting nothing in that one.
Wait, what would this be? One?
I got you there.
Some
Yeah.
little flowers kind of.
1S. There's a camera right there.
Stop looking at me.
No, I don't like her up.
Our flowers just keep growing.
Oh, 2, oh, okay.
Playing my
Are
game.
you guys wrestling at home this week?
Oh, look at that.
Yeah.
That's crazy.
Do they have cheerleaders?
Yeah, that's-
come and
I'm
cheer
saying, yeah,
you?
'cause that's one
Well, in each corner.
thing.
I know, but other schools.
Buster does. Wait a minute.
That's two.
Wrestling matches.
No, it's just one.
Oh, yeah.
I'm just gonna put.
Student basketball team, so-
That is not straight, but.
Oh, so you gotta buy like.
Grim's mine than yours.
I think it's from legs.
Yours looks like a turtle, Bailey. Mine does? Yeah.
So you have
With
one.
one little leg.
Mine's a little flower.
So then we
I
have
don't
these.
know, do I gotta go get my vest and play or what? Can me and Bailey go get my vest from the gym and film?
Hurry.
Oh, okay.
Sorry.
That's what that is. I was confused about that.
Quit standing in front of the camera. Can't help it.
I think you should watch Mr.
Is he videoing it? Yeah, he is.
All right, so,
No, bro, it's video.
boron, 1, 2, 3, 4, 5, there's his 5 electrons. Carbon, 1, 2, 3, 4, 5, 6 electrons. Okay? And we'll, later on we'll talk about this, but, right, we can put 2 in that space, that's fine. Then we can go 1, 2, 3, 4, 5, 6, 7, that's okay.
I didn't do
That looks
No, this is okay, right? So, okay, well, I'll come back to it. 8, 1, 2, 3, 4, 5, 6, 7, 8, that's fine. We just can't put 3 in there, right? We can only put 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So, this is actually an interesting question, or interesting point. What is there a correct way? Putting 2 in the same space, or spreading them out before you have to pair them? Right, because that's the 2 scenarios. So it turns out that, and the same thing I was talking with Ashlyn about the energy, technically, pairing them is less stable than spreading them out. Okay, remember, we talked photons and energy. So, what's the ground state? You know, the ground state, what is the lowest possible energy level for all the electrons to be in? Well, it just so happens that the ground state So the lowest possible is to spread them out evenly before you have to pair them. And that's actually a rule when you think about it. All right. Good, this looks good, right? So we just we fill the space, we get all these spaces, they're pointing in different directions. Okay, once we get over here to neon with 10, like, can we put any more electrons there? No, because our X has 2, our Y has 2, and our Z has 2. That's it. We can't fill up any more. So in order to go to, what's the next one after neon? Sodium, right? So in order to go to sodium and add one more electron, what are we gonna have to do? We gotta, and now we go to the third level. So sodium is gonna look just like this, but with another circle. Okay, so it's gonna be a 1s, a 2s, and then the 2 p's, and then a 3s.
So the max for one circle is like 6. That's what it.
Well, let's talk max. What's the max for 1s? 2. What's the max for 2s? Okay. So what's the max for the first energy level? 2. What's the max for the second energy level? Well, we have 2s with 2 electrons. And then we have 2p, because this is 2p. But how many electrons can fit in 2p? So 2 plus 6, 8. So the max is 8.
Okay.
2 of them are in the S, 6 of them are in the P. Okay. How do we know 6? There's 3 spaces, the X space, the Y space, and the Z space, and we can fit 2 in each space. Okay. Okay, what else? There's lots we can talk about here.
Wait, I have a question.
Question.
So with fluorine, where would you put the 90?
Say that one more time.
With fluorine, where would you put the 90?
Fluorine, where we put the nitrogen. So, where we put it, there's the 9th one would go. Well, if we technically did it, it would go like this. We'd go X, or X, Y, Z. So that's 1, 2, 3, 4, 5, 6, 7. Then we would start over again. There's 8, and there's 9. Okay? And now we have
The empty space.
an empty space. That's significant because then for neon then that one is going to be filled up. Okay? Other questions?
It's hot in here. It's a nap time. It felt really good in the hallway.
Okay. Then here's one for you.
He was moving one.
If we think about where do electrons start filling?
What do you mean, where they start from?
Where do they start filling?
The ground state. The first one.
First,
S.
they start filling here, right? Hydrogen has 1 electron. Can hydrogen exist out there without an electron?
No, because it needs an electron.
Yeah, I can.
Yes, it can.
Yes.
It doesn't need an electron.
It doesn't need an electron. So actually, interestingly enough, hydrogen
That's the only one that can do that.
can be out there all by its lonesome proton.
Is it the only one that can do that though?
No neutron.
Maybe helium can, I'm not 100%,
Is
but
it because it's
protons, single protons can exist.
Yeah, that's just a thing with the single proton. Unlike carbon, which is 6.
So if this single proton just happens to accumulate an electron, where is it going to go?
The first one.
First one.
Okay, lowest. Okay. So when we start filling at 1s.
Yes.
Okay. When do we stop filling, or when is an energy level full?
After 2.
So for hydrogen and helium, like 1 is full. And then we start filling another one. So we started here, and we started here, and we were full here. Okay, we'll come back. Okay, all right. Look at your periodic table. What is the relationship between hydrogen and lithium's position on the periodic
They're
table?
in the same column.
So lithium is right underneath it?
Yes.
Okay, so we started filling, we were full. We started filling, continuing to fill. What happens at neon? Full. And then what did we start at sodium?
The third.
We started the third. Well, where's sodium's relationship in that?
It's the 4th.
So sodium is below lithium?
Yes. Oh my gosh. I think I'm onto something.
Okay,
I'm
so.
not onto something.
So hydrogen, we started 1s. Lithium, we started 2s.
Wait, I see it now.
Sodium, we started 3s. So probably potassium
4s.
is going to be 4s.
Oh my gosh.
Okay,
Okay.
good. 4s. Wait. Let's look at this. Helium is, we filled. So now we're looking at right before we started filling, when we were actually full.
Helium. Neon.
Helium and then
Neon.
neon. And so helium was in the 1s, but 1s. Neon,
2s.
2s and 2p,
2s and 2p.
right? Because it's 2s and 2p.
Does that mean argon will be 3s and 3p?
So argon, good. Then that means it's worth.
Am I onto something, man? Is the brain braining?
Okay, and then yeah, so krypton must be like
4.
4. Before we get too crazy here,
4s and 4p?
what period is hydrogen in?
1.
And hydrogen starts the first period.
Yes.
Lithium starts the,
2nd.
sodium starts the,
3rd.
potassium.
4.
Helium ends
The second.
the first period.
Start the
Neon ends,
They don't start, but they end it.
they end the period, right? They're on the end of the period. Argon ends the 3rd period. Krypton ends the 4th period. Okay. Good. That's good. What do we call these elements? What's their family name?
It is
Alkali metals?
Alkali. What do we call this
noble
family?
gases.
No, we're good.
Oh my.
Noble gases. Okay. Okay. This is good. Are we good?
Yes.
We get it? Because I'm gonna ask another one. These start the period.
Yes.
Are they all on the same? They all on the same family? These end the period.
They're the same family. So that means the other things in the same family will be the same.
Okay.
Fluorine.
Who do we call the fluorine group? What's our technical name?
Halogen.
Halogens. Okay. And they all what?
They all have an empty base.
They all have an empty space. One empty space.
They will all have.
So when we go to fluorine, chlorine, bromine, iodine, they all have one empty space.
That's nice.
Where is their empty space gonna be?
Z.
This is 2
2P.
P, 1, 2, 3, 4,
5.
5, 2P5.
Oh my god.
So chlorine is gonna be
It's only 2P5.
3P5.
4P5. 4P5.
And iodine, no, bromine,
5,
4P5. And iodine, 5P5. And they're all in the same family. So, as we go into this, you're going to see that they're in a family because they have similar reactivities. All
So
right,
they have
fine.
similar numbers.
Why do you think they have similar reactivities?
Well, it's
Because
because
they
of their
have
state.
similar numbers. Like me.
Because they have similar electron structure.
Yep, I knew that.
Yes, I knew that.
Okay, so they have similar electron structure. Where? So a special name was given to the special electrons. You know, when we get bigger and bigger, the electrons on the inside, are they going to be important? Notice we have some electrons on the inside and then some that are on the very outside.
You're just gonna be in there.
What do we call the electrons on the very outside?
Valence.
Oh, valence.
Whatever Sean just said. Valence electrons.
Valence. All right. So going through these configurations is going to give us a clue as to the valence structure and the valence structure. So alkali metals, they all have the same valence structure. They all have one electron out there at the very edge.
That's nice.
Noble gases, they're all full
They all
up to the very edge.
So well started.
What's that? What? Valence?
Yeah.
Valence is just the outermost electron.
Outermost electron.
Outermost electron.
Yeah.
I think it's bedtime.
Okay. What else can we talk about?
How your day was?
Oh, two things.
Okay.
And then you can come back on the board. So remember which one you did, because I'll have you do. We're gonna do one thing. All right. Would we want to draw a picture for Would we want to draw a picture for iron?
Probably not.
Which one is?
I mean sodium, right? Sodium's gonna get crazy.
Which you find out?
I'll tell you that.
Point it out.
All right, we drew our third ring. Well, then we're gonna have 3p also
Why must you do this?
out
I don't
there.
like this game.
Okay, but can you see that we're just gonna start layering everything on top of each
Yes,
other?
that's why
Yeah.
it's sticky.
Okay, so we need a better way to kind of abbreviate how we represent this.
Do you just
So,
not draw the inside bits?
all right, so hydrogen is gonna be this. Hydrogen. How could we describe where the electron is in hydrogen?
One.
It's in the first energy level. S,
One.
1.
One is one.
And we're gonna use an exponent to say there is one of them. Okay, this is an abbreviated notation.
Let's try.
Okay, another way to show it would be this way. 1s, and we show that it has electron spin. So this is a spin notation or an orbital notation.
What if you're doing neon? Would you have to put like 12 arrows?
Ah, let's talk about it. Okay, let's go next. Boom. Helium is going to be 1s and 2 electrons, one spinning up, one spinning down. Or we could just write it as 1s2. Talk to me. Lithium, what do you think?
What
we have 1s.
So would it be just 1s2 and then 2s?
2s.
2s.
1.
So, no, because 2s has only one electron. So helium's going to be 1s and 2s.
Oh, so you just put that.
Okay, so for helium, we did 1s2, 2s2.
If you're not writing in your notebook now, that's okay. You're going to have lots of practice things to do. Right?
Not to do, right?
Both of them? Writing them both ways?
Yeah, and I'll even show you.
Oh god, I'm gonna shoot
So
this.
then boron would be 1s2, 2s2, 3s1.
I'm not
2p3, right?
Okay.
Oh,
So yeah, so what would, so boron is 1s and 2 and 2s 2 and 2p 1.
Okay.
All right, but let's now think about it because this really doesn't show the potential. All right, so we could also write it as 1s, 2s, and 2p, but how many spaces do we have in 2p? We can hold 6 electrons, but how many spaces?
3.
X, Y, and Z. I know. Okay, so S2, 1s2, 2s2, and 2p1. Okay. Okay, this is where I'm going to let you then come up and do your notation for your.
Who did that?
So I see
Right above.
So Chris was the one I did there. I went like.
Alright, so we're gonna
Oh, mom was
I
good.
thought I was writing my essay. Do you want us to write it this way?
And then you're gonna have your X. Get 3. No, we don't have a third one. No, we
Why don't
should
we have
though.
a-
We should have a third one.
Is it like P2?
Since there's no,
P2,
there
P2?
is no
No, this
energies
one's
that are associated
Q.
with one.
Yeah.
You're right.
Oh yeah, we still got
Yay.
No, you're wrong.
Hey,
Is it 3
Explain
p.m.?
chill out. I don't remember.
3p would happen after sodium.
Oh, yeah.
What are you doing? You don't know.
Never joined it.
To be honest.
That was.
I don't know. I don't think we got that.
Mr. Scribbler.
Might be good.
Read a fact check.
You need a fact check?
Yeah. I don't think that's right.
Ew.
That's some very.
So 1s, yep. 2s, yep. What is that number?
One.
Oh, that's
One.
Oh, I'm talking about mine. Not yours.
Oh.
This is 1.
I'm trying
Except
to
for
look
is
at
it,
Google
this is actually 2.
My god, I watched it.
Oh yeah, yeah, 2B.
Yeah, girl. That's
So you
cool.
changed the 2 on my last P to a 1.
Yep, and it's
Yeah.
2p because it's completely full, so every space.
Like this.
That's
Yeah.
two.
Yeah, or it goes on one space.
That's true.
Freaking random. Like,
I confused myself.
Like,
So you have 1s, 2,
One is 2.
you have 2s2, and now you have 2p with 1.
oh, so mine was.
I don't know what I was trying to do.
wait, I'm really confused.
So,
So you have 1s with 2.
this
You
is
have 2s with 2. And then you have, this is actually 2P.
Freaking marker. She's not.
Who's that? I thought it was.
Oh, I checked. What did I do here?
Well, there's an X space, a Z space,
X
and a
and
Y.
Z.
X, Y, and Z.
I can't do it.
It wasn't me.
Don't look at me, it's.
I hope
And he started emoting on me. And he didn't, he died.
Just mark yourself.
I had no problem.
Stop it, Ryan. This face I need to write on.
I got you. Let me cook. Okay.
All right.
I go to the bathroom.
Yeah, very good.
X,
Can I draw a smiley face on the board?
No, okay, erase that. Do this. You embarrass me. You have to write Z. You stupid.
Happy?
Yes.
Are you happy with it?
I'm happy. Okay,
Okay.
so good. So
That's my stick.
we have carbon at 6, so 1s2, 2s2, 2p2, and there's 2 electrons there. Now, this is like what we talked about. So by convention, when you go x, y, z, you want to spread them out first before you turn them up. Okay? So this would, x and y, this would be more correct, having 1 in x and 1 in y. And then 1 in x, 1 in y, 1 in z. There's 3 there, so you get 1, 2, 3. And then
What?
x, y, z, and we have the 4.
And then
So
4.
now we go back.
No,
You
because, why?
Ground, there's ground state energy, right? Lowest energy. Okay, 2p5. Good. And then 2p6.
angry.
Good. So,
I have.
what would sodium look like?
I'm gonna send it first.
Do you, I think first of all, do you see that the pattern just continues to build on itself
Unfortunately.
as you add electrons?
Yes.
It's never not going to be that. It's always going to be that.
Yes.
Okay? So, for sodium, what do we start with?
1S.
1s. And how many electrons do we have in it?
2.
And then 2s and
2.
then
3s. Right.
oh, before 3s we have 2p.
Oh, 4, 3s. 2p.
And it was full. So it's gonna be 6. And then
Then
3s. And how many?
for sodium.
It's the next element. So
1. I knew it.
who's next to sodium? Magnesium?
Magnesium.
So magnesium is gonna be
Oh, there's sodium.
Sodium becomes
3s2.
3s2.
Haha.
And then 3s2 and 3s.
But
No.
well, 3s2. Now that s2, that's it. We can't put any more in that, so we go to 3p.
Yeah.
4p, 4.
Notice that after 3s, what do we jump across to? Aluminum.
Yeah.
Yeah,
Right, there's that gap. There's that gap there because we jump from
It's
S
the D block.
to P.
Ah.
Because S1 and S2, that's full, so we have to go to a new shape.
So do the other ones not do that then? So they don't jump?
Technically they do, but the periodic table is written in such a way where it's hard to prove.
Yes, it is.
But
I agree.
It's hard to
as we go through here, we're gonna see that something different, well, okay. We started filling S shapes, then we started filling P, then we started filling D. That's what will be next, and we will get there, okay? How many electrons, well, let me back up. How many electrons can S hold?
3.
Ooh, it needs 3, but that can hold 2.
S can only hold 2.
Yeah.
How many can P hold?
6.
1, 2, 3, 4, 5, 6.
Oh, that's smart.
So how many do you think D can hold?
A lot.
12.
13, 14,
12.
9,
10.
18.
Oh, because it starts at
Because this is S. So we start at Scandia. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, right.
And then once we get to zinc, where are we at?
And then you're back to
We're
the-
back.
You're back to P.
P.
That makes it. That makes more sense. I was
Okay?
confused.
And then you keep going. Then now we're to an element with 56 electrons.
Holy crap.
Whoa. There's only 2.
All right. So right, we're just stacking them all in there.
Yes, we are.
But now we're far enough away from the nucleus that we get F electrons in there. And how many electrons can fit in the F space?
F.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14.
And when that's full, we jump to D, and then we
Then
jump
we
to
do
P.
10. Again.
Are there 8 S electrons?
8 S.
Sure.
7.
No,
There's 7.
that we know. Because 7S.
We're gonna find the new
Oh.
one.
Yeah, there's 7.
I can't see those.
Somebody one day was
That's
like,
why I gave you your own
I
periodic table.
think
I'm gonna discover a new one.
Indium is the movie number 77.
Indium?
You think that there- It doesn't necessarily have an answer.
I think there was some legal benefits in I mean, anyway,
IR.
Oh, maybe it's
Like,
I like
like
for you.
in space, because you just like, I think it's something they don't have.
somewhere.
Yeah. And it's not like the astronauts or something like that.
I wish I was getting
Oh, yeah, because we really don't know what's in a black hole.
Those kinds of bugs.
Okay, questions on any of those?
No.
Connor.
Can we be done?
I think I understand.
My tummy hurts. That's my comment.
My comment.
My tummy hurts.
Yeah.
Yours does too? I'm sorry to hear that.
Oh, twins. Where have you been?